Hi class, welcome to our lecture on the carbohydrates. So what kinds of foods do you think contain carbohydrates? And what types of foods do you think don't have any carbohydrates? I know a lot of times when people think of carbohydrates, they think of sweets, but sweets are absolutely not the only form of carbohydrates out there. And for purposes of this lecture, I'll probably refer to carbohydrates as carbs. We're going to learn about all the many sources out there today. Some foods that generally don't have carbohydrates would be any foods that are fat-based, such as oils, or many protein foods don't contain carbohydrates, specifically animal protein foods. Plant sources of protein do, but most animal sources of protein do not. Carbohydrates. So carbohydrates are similar to lipids in that they are composed of carbon, hydrogen, and oxygen. And this is how their name sounds: carbohydrate, meaning carbon and hydration from the water. There are simple carbohydrates, and then there are more what they call complex carbohydrates. Simple carbohydrates include sugars, and we have the monosaccharides, which means one sugar, as well as the disaccharides, which means two sugars. Complex carbs include starch and fiber, and both of these are made up of very long chains of sugars in different orientations. So this is just kind of an introductory chemical diagram on how chemical bonds form and how they're drawn. So H is hydrogen. Hydrogens form one bond. O is oxygen. Oxygens generally form two bonds. N is nitrogen, which forms three bonds. And C is carbon, which forms four bonds. Monosaccharides. So monosaccharides literally mean one sugar. And these are single sugars that occur in foods that we eat. They are glucose, fructose, and galactose. Fructose is on the far left, glucose is in the middle, and galactose is on the right. You might notice that the only difference between glucose and galactose is where that oxygen and hydrogen group are located around that ring structure. So in glucose, that bond is pointing down, and in galactose, that OH group is pointing up. All of these have the same chemical formula, so they all have 6 carbons, 12 hydrogens, and 6 oxygens. They're just arranged in different orientations. So what do they do for us? Glucose is what we know as blood sugar or dextrose, and we do eat glucose also in foods. Fructose is considered fruit sugar or levulose. I don't hear that name very often, but it occurs naturally in fruits, honey, and different saps. Fructose is relatively sweet. And then galactose doesn't really occur as a single molecule in nature, but occurs as part of the molecule lactose, which is sugar that comes from dairy products. And lactose is made up of a glucose and a galactose. So this is just, again, what glucose looks like. Disaccharides. The disaccharides are groups of 2 sugars. So 2 of those single sugars combine to form a disaccharide. The first one is maltose, sometimes known as malt sugar, and this is made from 2 glucoses. Sucrose is what we commonly know as table sugar, and this is made from a glucose and a fructose. Lactose, like I already mentioned, is milk sugar and made from a glucose and galactose. Complex carbohydrates occur when multiple single sugars linked together. And in our body, or in the foods that we eat, these generally occur as starches and fibers. Glycogen. So glycogen is how animals, humans included, can store glucose. And we store glucose in the liver and the muscle, and then we can break down that glycogen so that individual glucose particles will be released to the bloodstream or utilized for energy. Starch is how plants store their sugars, and we are able to digest starches. These are some pictures of glycogen and starch. Glycogen is very branched, and so we can break it down really quickly, which is good because this way glucose can get to our bloodstream. Starch is also branched, but the branches are a little bit more orderly. You can see they're pretty kind of linear there. And then starch has both branched and unbranched components. The branched component of starch is called amylopectin. The unbranched component of starch is considered amylose. Fiber. So fiber is not starch, and we cannot digest fiber. There are two different types of fiber. There are soluble fibers and insoluble fibers, and fibers are classified by their solubility in water. So do they disperse easily in water? Soluble fibers do disperse easily in water, and these are things like the insides of an apple, the insides of a pear, insides of a strawberry, inside of the banana, oatmeal, things like that. Insoluble fibers do not dissolve in water, and these would be like the outer husks on a corn, or even the kernel of a corn, or the skin around the almond seed, nuts, the outer shell of some nuts. All right, so this is a diagram of different sources of carbohydrates and kind of where they go in our body. So starting with monosaccharides, those are the simplest sugars. They can combine to form disaccharides, which would be pairs of two sugars. Those disaccharides can then become complex carbohydrates, which are polysaccharides that have 10 to 1,000 units in them. And the polysaccharides would be either starches, fibers, or glycogen. Glycogen is stored in the liver and muscle. Starches are made by plants, and fibers are undigestible by humans. Where do the carbs come from? Like I said, carbs are in pretty much everything except for meat sources of protein. So you don't really find carbs in meat. You do find carbs in dairy, however, and it's the carb lactose. These are just some sources of carbohydrates. You can see got baked potato, Coca-Cola, M&Ms, rice, corn, beans, orange, milk. So like I started off with in the beginning, not all carbs taste sweet. In fact, many carbs are not sweet at all. So carbs are not just sugars and candies and sodas. They're also the starches, the rices, the grains, etc. Whole grains. Whole grains have some really good health benefits because whole grains will have fiber in them, and fiber can help lower our risk of cardiovascular disease, as well as, anything with cardiovascular disease, but heart attack and stroke, the number one killer of people in the United States. Fiber is one of the benefits. They are also rich in minerals and vitamins. During the milling process, a lot of the vitamins and minerals from the whole grain are stripped and disposed of, and then later they're added back to refined grains, but not all of them are added back. Phytochemicals are chemicals that naturally occur in plant foods and have some function in our body, such as antioxidants or anti-inflammatories. And then here it says reduce the risk of CVD, which is cardiovascular disease, DM, diabetes, cancer, and obesity. When we eat whole grains, we actually feel more full. And this feeling of fullness reduces spikes in blood sugar as well as helps us to eat less. Whole grains and white grains. So white whole wheat is still whole wheat. It is possible to have a white colored bread that is still whole wheat. Usually we see whole wheat as brown, and that's because most of the wheat is kind of a red color, which when we cook with it, it kind of turns brown. So most wheat that we use is actually a red color. However, it is possible to have a white whole wheat. You can look for these stamps indicating that a food is made with some whole grain. So it might have 8 grams or more per serving, or 16 grams or more per serving. Types of whole grains. So I talked about wheat. However, any of these grains could be considered whole grains as long as they haven't been milled and processed. How do we digest carbs? So carb digestion starts in the mouth, actually with something called salivary amylase. And amylase can start to break down some carbohydrates in the mouth. It's actually inactivated when it hits the stomach, though. Also in the mouth, we have some mechanical digestion. So by chewing our foods, we can expose more of the surface areas to enzymes. And then as those foods become a bolus and move down into the stomach, more of the enzymes and the stomach acid can access the surface area of those foods. In the small intestine, we have different enzymes that are released to help further digest our carbohydrates. And so this is where the majority of carbohydrate absorption and digestion takes place. Most of those carbs are transferred across the intestinal cells and taken up into the bloodstream. And then the large intestine really doesn't have much carb digestion going on, except for fibers that we haven't digested. Fibers end up in the large intestine, and fibers can be partially broken down by our healthy microbiome, so our bacteria living in the large intestine. So this is a picture of the process of carb digestion and absorption. Again, in the mouth, there is salivary amylase. There's also maltose. In the stomach, that salivary amylase is inactivated, like I said. The pancreas will release pancreatic enzymes. Amylase is one of them that can further break down starch molecules. And then the small intestine will itself release some enzymes to break down disaccharides. Has lactase, maltase, and sucrase enzymes. Absorption of glucose, fructose, and galactose happens through the cells of the small intestine. This goes directly to the portal vein, which intersects with the liver to be processed. And then fiber is digested and absorbed, well, not digested or absorbed, but fiber is moving into the large intestine where bacteria can break some of that down. Digestive enzymes. So these are digestive enzymes that the pancreas will secrete into the small intestine, the duodenum of the small intestine, to break down disaccharides into monosaccharide units. Once disaccharides have been broken down into monosaccharides, they're able to travel across the intestinal villi into circulatory system, and they travel to the portal vein, which intersects with the liver. In the liver, galactose and fructose have similar metabolic pathways with glucose, and glucose is given off to cells of the body to use for energy. So after all the monosaccharides have been absorbed, what is left to pass into the colon? Hopefully you guys said fiber. Fiber will be passed into the colon. And so fiber, especially insoluble fiber, we're not going to be breaking this down. Bacteria are going to be using this fiber to break down. But fiber has many functions. One of the things it can do is bind bile. And when it binds bile, that bile gets excreted. The way our body makes bile is through cholesterol. And so our body has to then make more cholesterol. This is fiber. So here we go. Fiber not digested in the mouth, but is broken down by us chewing it. Not digested in the stomach, not digested in the small intestine, but does slow down absorption of nutrients. In the large intestine, fiber passes intact, and here bacterial enzymes can break it down, creating fatty acids, which we actually use, as well as gas, which most of us don't want to use and find unpleasant. But it's actually really, really healthy to have gas because that means your bacteria are eating and your bacteria are working, breaking down this fiber for you. Benefits of fiber. So fiber keeps you regular. They say an apple a day keeps the doctor away. Apples have both soluble and insoluble fiber, so I always kind of think of them as good fiber foods. So fiber helps provide bulk to the GI tract as well as get nutrients and food kind of flowing through that GI tract. Helps keep things kind of going. Fiber can limit absorption of cholesterol and bile acids. I said that the fiber could bind to these things and be excreted, which will then cause your body to have to make more of them, which will then result in lower levels of circulating cholesterol, which is good. And so by this, it can reduce your incidence of cardiovascular disease and gallstones. Fiber is food for your bacteria in the large intestine. They do produce fatty acids. They can also produce some biotin and vitamin K. Fiber slows glucose absorption, so eating high fiber foods will lead to kind of lower, more steady rises in glucose than eating low fiber or no fiber foods. And this can also give you kind of prolonged energy and make you feel full longer. How much fiber do we need? So these are just two nutrition facts compared, and I believe that these are for different cereals, but you could see one of them has 7 grams of fiber and the other one has 1 gram of fiber. So the one with the 7 grams of fiber would be a much better choice for fiber recommendations. The AI for fiber is 25 grams a day for women and 38 grams a day for men. And most people do not meet their recommended intakes for fiber. Our diets are significantly lacking in fiber. Some sources of fiber, both soluble and insoluble. Here you can see where the soluble fiber would come from versus the insoluble. Soluble fiber helps lower blood cholesterol, slow glucose absorption, hold moisture, etc. More sources of fiber. This tells you exactly how many grams each food category has. So most grains have 1 to 2, vegetables 2 to 3, fruit 2 grams, and legumes 6 to 8. So remember, we want to have 25 to 38 grams. And so if we're just eating grains all day, we're going to have to eat a lot of grains. If we add fruits, vegetables, and legumes in, we're not going to have to eat so much of those. And if we eat a lot of legumes, we really won't have to eat that much at all because they're so fiber packed. Lactose intolerance. So we discussed that disaccharides are broken down into monosaccharides in the small intestine by enzymes secreted into the small intestine. And one of those disaccharides is lactose, and lactose is made of a glucose and galactose. However, it's possible that people don't produce enough of the enzyme needed to break that lactose down. And so they are considered lactose intolerant if they can't separate the glucose from the galactose in that lactose molecule. If they can't separate this, the lactose goes complete, so the lactose remains intact as it moves through the digestive tract, and this can cause gas, bloating, abdominal pain, just some general discomfort. It might be genetic, and it's actually very, very prevalent. It's estimated that 30 to 50 million people worldwide have it. People who have this usually can consume some lactose in small amounts. but not large quantities. And sometimes people with lactose intolerance can consume fermented forms of dairy, such as yogurt or cheeses, because some of the bacteria in those fermentation processes can actually begin to break down the lactose. Lactose content in selected foods. So you can see it's actually pretty high in yogurt, but some of the bacteria can break some of that down. This is on a case-by-case basis if people can tolerate it or not. From clients I have worked with, I have heard that many people with lactose intolerance are able to tolerate sometimes yogurt and sometimes cheeses in small quantities. GI issues. So what can go wrong in our gastrointestinal tract? So many things. What you see here is something called diverticula. And diverticula are little pockets that kind of form, or little outpouches that kind of form in the large intestine. And they usually form if there has been too much pressure on that intestinal wall, which could happen during constipation, where you're kind of trying to force yourself to have a bowel movement and the high pressure isn't allowing that to happen. The high pressure can cause parts of that intestinal wall to bulge out, and these little pouches can form, and they're called diverticula. Diverticula themselves aren't bad. However, it's possible that these little pouches become inflamed or infected. And in that case, you can have something called diverticulitis, which is very painful and can lead to malabsorption as well as like hospitalization because it's so painful. So once we have digested and absorbed our carbohydrates, what can we do with them? I want you to think of 3 things. 3 things we can do with our carbohydrates. Can we build proteins with them? No. Can we make essential fatty acids with them? No. First of all, we can use them for energy. This is our body's preferred source of energy. Most parts of the brain and central nervous system want glucose as their energy source, as well as red blood cells. We can store glucose as glycogen in the liver and muscle so that we can break that glycogen down later to use for energy or to release to the bloodstream. And we can convert glucose to fat if we have eaten an excessive amount of it, if our glycogen stores are all full. After the body uses up glucose supplied by the foods we eat, how does it continue to provide energy to the cells between meals and overnight? So the answer to this is glycogen, as well as eventually fat stores. Glycogen is stored in the muscles and the liver, and glycogen can be broken down very quickly to provide energy for the cells, increase blood sugar levels. However, this energy source usually only lasts a few hours. So after that, you would probably begin to break down fats. And fat breakdown isn't exactly perfect, but you can break down fats to help replenish some of this energy. One of the things that happens as you break down fats in the absence of carbohydrates, however, is something called ketone body formation. And ketone body formation could potentially be harmful if those ketones are in very high quantities. So when there is no glucose, what does our body do? Our body will next go to fat. When we break down fat, I mentioned that ketone bodies can form. So this happens when there is not enough carbohydrate in our diet, or that we've been eating, or we've been fasting for a long time, or we've even been starving. So ketone bodies will form as part of incomplete breakdown of fats. And if these ketone bodies build up, something called ketosis can happen, which is when there are too many ketone bodies in the blood and the urine, and this actually changes the pH of the blood, which can be potentially very dangerous. Our body, like I said, prefers glucose, and daily we need about 50 to 100 grams of carbohydrates to prevent ketosis. So how does the body maintain glucose homeostasis? Glucose homeostasis refers to balancing the appropriate levels of glucose in the bloodstream so there is plenty of glucose available to the cells. There are different hormonal mechanisms that we use to balance this, as well as different storage forms of glucose. Glycogen we can use as a storage form of glucose that can help us maintain our blood homeostasis. And so we'll see this coming up. All right, so normal blood glucose levels fasting, meaning you have not eaten, are 70 to 100 milligrams per deciliter, and normal blood glucose levels are maintained primarily by two hormones. There are a few other hormones, but two main hormones that help to regulate blood sugar are insulin and glucagon. Insulin is a hormone secreted by cells in the pancreas, and insulin is secreted in response to you consuming a meal that contains carbohydrates. When you eat a meal that contains carbohydrates, your blood glucose levels will rise, and insulin will be secreted in response to that. Insulin allows glucose to be taken from the bloodstream and into the cells. And so insulin can then lower blood glucose levels. Glucagon is the opposite of insulin, and glucagon is secreted when you have not had a meal containing carb for a long time, or when you're fasting and the blood sugar levels have become too low. And what glucagon does is it causes glycogen to be broken down into glucose so that glucose can be released to the blood. So glucagon increases blood glucose. Epinephrine. Epinephrine is a third hormone that is involved in blood sugar regulation. However, the primary hormones are insulin and glucagon. But epinephrine is considered our flight or fight hormone, and it's otherwise known as adrenaline. And in the situation that we literally did have to flight or fight, meaning run away or fight, we would want as much glucose available to our cells as possible. So epinephrine works to increase blood glucose. This way, glucose can be used for energy, and glucose can be used by our muscle cells. This is a diagram of blood glucose levels over time and how hormones will respond. After you eat a carb-containing meal, you'll have high blood glucose. The pancreas will release insulin. That insulin will cause glucose to be taken up to the cells. It will also convert glucose to glycogen. Then your blood sugar will go back to normal. If you have low blood glucose, your pancreas will release glucagon, which will cause breakdown of glycogen to glucose molecules. And if you have run out of glycogen, it can also help cause gluconeogenesis, which is the formation of glucose from non-glucose molecules. Diabetes. So I'm sure that everybody has at least heard of diabetes. Millions and millions of people worldwide are affected by diabetes, and almost everybody either has been affected personally or knows somebody who has been. There are two main types of diabetes. There is type 1 and type 2. And type 1 is actually an autoimmune disease, meaning the body attacks itself. And specifically in this instance, the body attacks the cells in the pancreas, the beta cells. When the body attacks these cells can no longer produce insulin, and so the body can't bring glucose into the cells, and glucose circulates in the bloodstream at really high levels, which can be very dangerous, eventually even leading to death if undiagnosed or untreated. Type 2 diabetes, the body does produce insulin, but our cells aren't very receptive to it. or our body doesn't produce enough insulin. And so usually oral medications are given to help treat type 2 diabetes. In some cases, type 2 diabetics will also need insulin if their own just simply isn't working well enough. And both types of diabetics can benefit from diet and exercise. So this is the blood sugar of a diabetic versus a non-diabetic person after eating. And you can see that glucose is given at this time 0. For a non-diabetic, the blood sugar kind of raises. It gets to about 140, 150, and then it slowly declines. That's considered normal. For somebody with diabetes, their blood sugar raises, but it never goes down because they don't have enough insulin, or the insulin they have isn't responding to the cells. It is possible for somebody with diabetes, or actually anybody in general, to have low blood sugar levels, and low blood sugar levels are termed hypoglycemia. Anytime you see hypo, that means low. So hypoglycemia. When you have hypoglycemia, it usually means that your blood sugars are less than 70. And this is much more common in diabetics than just the general population. And some of the medications that diabetics take to treat diabetes have this as a potential side effect. Also, if diabetic was not eating any carb-containing foods, this could happen. Or if a diabetic had exercised extensively, exercise can naturally reduce blood sugar. So say they were exercising and not eating, this could also happen. Glycemic response. The glycemic response is the extent to which a food raises the blood glucose concentration and causes insulin to be secreted. And glycemic index can classify foods according to their potential to raise blood glucose. So these are both potentially very beneficial categorization systems, especially for people with diabetes. Some food choices are low in glycemic index, such as whole grains, vegetables, legumes, milk, and milk products, and some foods are high, causing very quick blood sugar spikes. Just think, how many carbs should we eat per day? So the recommendation for daily carbs is 45 to 65% of our total calories should come from carbohydrates. So on a 2,000 calorie diet, that's about 300 grams of carbohydrates. How much added sugar should we have a day? Oh goodness, according to the Food and Nutrition Board, we can have 25% or less of our total calories coming from added sugars. Added sugars are literally sugars added into foods, like scoops of sugar being added into foods. These are not sugars that naturally occur in foods, such as fruits or grains or milk. These are added. And the problem with added sugars is they are very, very, very low nutrient. They have low nutrient density, meaning the only nutrient they supply is sugar and calories. They don't provide iron or calcium or vitamin D or essential fatty acids or anything like that. So the World Health Organization, which is abbreviated WHO, recommends a much more stringent level of added sugars, and this is at 10%. And I think that that is a lot better. Effects of sugars. So excess sugar can lead to obesity, chronic disease. We've already talked about cancer, heart disease, diabetes. It can lead to nutrient deficiencies. I just mentioned that sugar does not have nutrients. It's not very nutrient rich. It just has carbohydrates and calories. And it can lead to dental caries or cavities. Bacteria in our mouth can break down sugars, and when they break down sugars, they produce acid, which acid erodes our enamel. How much sugar are we eating? So we are eating an insane amount of sugar, 105 pounds of added sugar per year, and about 30 teaspoons each day of added sugar. That is just a phenomenal amount of added sugar. Sources of sugar in our diet. We've got soda, energy drinks, sports drinks as the number one source. High up there are fruit drinks, dairy, candy, ready-to-eat cereals, sugars, honey, yeast bread, and tea. Okay, how can we reduce added sugars in our diet? So, what can you think of that could help us reduce added sugars in our diet? Think about how you cook, think about how you prepare your food, think about when you're shopping, think about where you're shopping, even like which sections of the grocery store or which grocery store or grocery store versus farmer's market. How can you reduce sugars? So I want you to brainstorm at least 5 reasons, 5 ways to reduce sugars. High fructose corn syrup. High fructose corn syrup is a type of sugar, and high fructose corn syrup is made from cornstarch. And cornstarch is treated with an enzyme that converts glucose to fructose. Cornstarch naturally has both glucose and fructose, and cornstarch is categorized based on what percent of each of these it has. Normal cornstarch has about 50%, but high fructose corn syrup has about 55% fructose. So it's higher in fructose, and fructose is sweeter. We use these in processed foods because this is a very cheap product. It's also very kind of shelf stable, but this has a lot of negative issues. There is a relationship between high fructose corn syrup and LDL cholesterol, which is our bad cholesterol. What else? There is potentially a relationship between high fructose corn syrup and obesity just because its prevalence is huge. High fructose corn syrup is often in products such as ketchup, teriyaki sauce, noodles, hamburgers, processed hamburgers, hot dogs, salad dressings. It's in things that you would not think would need to have a sweetener added. Alternative sweeteners. So these are items that you can use, products you can use instead of sugar. Most of these sweeteners have reduced calories or they are so sweet that the amount of them that you need to use to taste sweetness is so small. Sugar alcohols are commonly used in sugar-free gums and sugar-free candies, and sugar alcohols do give us a little bit of caloric value, about 0.5 gram to 2.5 calories per grams, not 0.5 gram, 0.5 calorie to 2.5 calories per gram. Sugar alcohols are not broken down by bacteria in our mouth, so sugar alcohols can be potentially good alternatives, especially for a candy or a gum, something that's going to stay in your mouth a long time, because it won't cause that fermentation of the sugar and it won't cause acid buildup that leads to cavities. And in fact, sugar-free gums have actually been associated with lower incidence of cavities. These are some pictures of some of the sugar-free gums and how you would see sugar alcohols indicated on the labels. All right, we have made it to the end. So who did we talk about today, or what did we talk about today? We talked about ourselves, what we eat. When we're eating carbohydrates, we can eat them anywhere. And why do we need them? Because this is our body's number one fuel source. That is just one of the many reasons that we need carbohydrates. Okay, hope you enjoyed the lecture, and I will talk to you all next time.